All right, you got this. Let's learn some math. So welcome to, this is a methods and meanings review, and it's for law of sines and cosines, which a lot of students weren't able to get to last year. The right triangle trig is also part of this methods and meanings, but we're not in need of that as much because I'm going to be going over that as I do the review and preview, just to review it, because everybody got to trig last year in some way, shape, or form. So here we go. So you've already learned how to solve right triangles using trigonometric functions. And I would like to say it's, if you remember SOHCAHTOA, that's basically what we used at the end, and you were able to solve any right triangle that you were working with. Now you're going to learn how to solve oblique triangles using the law of sines or the law of cosines. And so we're just going to jump right in. This is the law of sines, basically. You have all of the angles A, B, and C, and you'll notice that they're all labeled with capital letters because the vertices are always labeled with capital letters. Those are your angles. And then you have the corresponding side lengths. So my angle C corresponds to the lowercase c for the side length, and that's the same for angle A and angle B. And also you'll see that it's simply just set up as sine A over A and sine B over B. You won't be using all three of those at the same time. You might just be solving for one of the four of these items. So you don't necessarily need to even look at C yet. So we'll get to that in the next slide as we start working through it. Hey there. This particular video is just a real quick video about how you should have the proper settings, the correct settings for when you're solving problems that deal with the law of sines and cosines or any kind of right triangle trig as well. To this point, that's what you've needed this calculator for. But in case you have forgotten or in case you have not learned this yet, you need to make sure that your calculator is in the correct mode. So what I'm going to do right now is I'm going to go to this mode. And I see this whole screen. It's like a menu. There's a lot of information here. But what we're focused on right now is this particular line right here. And right now it's on degree mode, which is really good. But most of the time, after you have like reset the memory, especially sometimes after you're using it in a classroom and a teacher might reset the memory of a classroom calculator, you need to make sure it is on degree mode. So let's just show you this by resetting the memory. So I'm going to hit second, and then the plus sign, which is mem, and then 7, 1, 2, enter. And then I'm going to show you why it's important for you to go back and check that mode. See how it's on radian right now? You need to go over here, scroll down to here, and change it to degree. Go over to degree, hit enter, and now you are in degree mode, and now you can properly solve problems using the calculator. If you get any weird answers like a length that is negative or something that just doesn't make sense, don't just trust that answer. Make sure that your mode is in degree mode, and then you'll be fine. All right, and that is it, and we'll get back to our work. Okay, here we are on a triangle that we need to solve. Notice it doesn't say A, B, and C, but it doesn't need to be, but you still see that my lowercase m and my uppercase m correspond the same with the N and the N and the L, and then even though L is not labeled there because it has a measure. Now the first thing we need to remember is when we're solving a triangle, it says solve triangle LMN. That means we need to come up with all of the angles and all of the side lengths. And hopefully you remember from last year the triangle sum theorem, where all of the interior angles of a triangle add up to 180 degrees. So I'm going to start with that first. So we need to find the measure of angle N because we know the other two. Well, that's just 180 degrees minus the sum of the two angles that we do know, which are 112 and 29. Okay, so we say 180 minus 141, which gives us 39 degrees. So that means the measure of angle N is 39 degrees. I'm going to come down here because we need three things to finish this triangle. I'm going to say the measure of angle N equals 39 degrees. But I know we also need to find lowercase m, which is the side length, and lowercase n, which is a side length. All right, and now I'm going to go ahead and erase this. Now you can always go back a few if you need to look at it more, but I will be erasing as I go just because we have a limited number of space on this particular slide. So the next thing I want to do is figure out the information I have. Well, I have 112 degrees and 29, and I have 22. I need to find a side. Oh, but I also already know this angle, so we're going to go ahead and put this in. This is 39 degrees, so I can now use that as well. In fact, I'm going to do that right now. I'm going to say, and this is where we're using the law of sines, the sine of 39 degrees will be over its corresponding side, which is n, and that's what we're trying to solve for. And then we have this that we know both of, so we can use those. So that equals the sine of 29 degrees over 22. And if you remember, you can use cross multiplication when you have two fractions, okay? So that's what I'm going to do right now. It means I'm just going to take the sine of 39 degrees and 22 and multiply them. So it's going to be 22 sine 39 equals n times the sine of 29 degrees. Now, I need to get n by itself because that's what we're solving for. So, most of you are probably ahead of me. I'm going to divide by the sine of 29 degrees. So, then we're going to figure out what that is in the calculator. All right, so I'm going to go to the calculator, and I'm going to put all of this in, but I'm going to make sure I always put parentheses around my numerator and denominator. It's not always needed. It's just a good safety precaution to make sure you get the right answers. So when I do that, I get a side length, and you can go ahead and type it in the calculator. You can pause and type it into the calculator, but I get 28.5577. And this one is asking for the nearest tenth. So that means I need to round it to this position. But because the second number is 5, I have to round it up. So it's 28.6. I'll put that over here. And then I will also put it in our diagram. I always have a diagram because it helps me organize my thoughts and where things are supposed to be. I'm going to go ahead and get rid of this so it doesn't clutter things up. And we'll leave those green lines in there because I just really like green, so that's totally fine. So we've got 28.6. Now we still have to solve for this particular problem right here. So we're going to go ahead and do that. But first, I'm going to go ahead and erase all of this. In just a second. It's very important that I get all the marks. It just drives me crazy when there's anything left over. Okay. Now we're going to set it up, and I'm going to go ahead and use the sine of 112 degrees because we are looking for this lowercase m. And I'm going to go ahead and use what was given, which is sine of 29 degrees again over 22. Again, we're going to do cross multiplication. Okay, and so that means I now have 22 times the sine of 112 over m. And that equals, I'm sorry, not over m. I'm sorry. I was daydreaming while I was writing. 22 times the sine of 112 equals m times the sine of 29 degrees. And then, just like on the last slide, I'm going to go ahead and divide by sine 29 and sine 29. That cancels out, and I'm going to type all of this into the calculator, and once I do that, I end up with 42.0743. And again, we're rounding to the nearest tenth. This is higher than 5. So my m will equal approximately 42.1. And that's our answer on that. I'll put it there. We have answered all of our questions for this particular problem. All right, we are now moving on. Here we go. Okay, what I'm going to do here is I'm going to have you pause this video, okay? And then I'm going to have you go and solve it. And the next slide, it will have the answer, okay? So go ahead and solve that. Work on that for me. Okay, so what you see on this particular slide is the solutions all worked out. A couple things I want to point out to you here. It does say round to the nearest tenth. Well, the nearest tenth can be to a 0. So don't forget that when you're doing this. Sometimes that's where people make the biggest mistakes when they're rounding. And then 11.8, and then also I use the triangle sum theorem to come up with the 75 degrees that are in that particular shape. So hopefully you got those correct. Those are the correct answers. If not, go back and look at your work and see what you did wrong perhaps. And if you have any questions, remember you can always leave questions in the comments and I will get back to you, I promise. Okay, let's move on. So this is the law of sines again, and we need to find the distance from the hot air balloon to each building. Well, first of all, we need to find the measure of angle Z. Well, the measure of angle Z equals 180 minus 62 plus 49. Well, 62 plus 49 is 111. So that means our angle measure for the measure of angle Z is 69 degrees. So we're going to go ahead and write that up there. Okay. This is just another way of solving for a triangle. It's just, they decided to put a little bit of context into it. So, all right. So that ends that, but they want to know X and Y. So let's go ahead and solve those. And you can actually pause the video if you want. I'm going to go ahead and just write out the work and talk through it. And if you have questions, you can either leave them in the comments or you can watch the video again. But this way, if you pause and try to do it yourself, you'll see what the actual answers are. So I'm actually going to pause this video and solve it, and you can come back and look at the solutions. There we go. Okay, so you can see how I went through and solved these, and I rounded them to the nearest tenth, but I showed you also what I got in decimal form so you could see how I rounded it, and you can compare my answer to yours. Again, if you have any questions, leave them in the comments, and that should take care of all of law of sines. Now let's jump into the law of cosines. Okay, this is, I thought I was going on a law of cosines. I forgot I have a guided practice for you guys to play with. So again, I have a multiple choice opportunity here, and the question is, how tall is this tree? So you are going to take a look at this, and then on the next slide, you'll see me solving for it, and we'll just move on from there. So go ahead, stop the video, try to solve it, pick the letter that you have, and then go to the next slide, and you will see the answer. So the first thing you had to do was figure out that 38 degrees. Then you had to set up your equation, and so I just threw a variable on there for the side length. And when I did that, I got to this number, which you can see rounds to 10.9 feet. Don't forget that unit of measurement. And that was the correct answer. So hopefully you ended up picking the right one. And now we'll move on to the law of cosines. Actually, I think we have one more slide to explain something that you probably won't have to worry about for a while, but just in case you get some weird answers. So we're going to move on to that one first. Okay, so what I want you to understand here is this is about law of sines. You're still going to do it. But there are going to be times when you end up miraculously or weirdly with a triangle that is possible in two different ways. And without going into too much detail, if I have a triangle and the side length, it connects to the other side, but it's a little longer than the height, which is right here, you could have two triangles. You could have this one out here, which makes one, or this side could swing around and cause another triangle. So you would have the whole triangle, and then you'd have this little sliver of a triangle here. That's called the ambiguous case, which is what I have underlined here. And I will go over this at some point, but what we're working on to this time, getting you through this chapter 1 of CPM's Algebra 2, you won't have to worry about the ambiguous case for a while. So I just want you to know, in case you get some weird situation where you're doing law of sines and you're like, why am I getting this weird answer? There is a possibility of two triangles having the same measure. It is pretty rare, but it can happen. And we'll talk about that another time. So let's just move on to the law of cosines I've been promising you, and I keep saying, no, it's not yet, but it's coming up. Okay, this is the law of cosines, and I'm going to show you two different ways. It could be with side angle side. So it could be that I know this side, and the included angle, that's side angle side. Or it could be side, 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 where I know all of the side lengths, but I don't know any of the angle measures. So that's two different things. And if you look at this, it sort of looks a little bit like the Pythagorean theorem, but it's just three different ways of writing the law of cosines. So it just depends on what you're looking for. And it will just be helpful for us to jump into a problem and go from there. So here we go. All right. What I like to do here is I'm going to show you a triangle I have drawn. If the sides of a triangle are A equals 19 feet, B equals 24.3 feet, and C equals 21.8 feet, what are each of the angles of the triangle? Okay, now they want us to find all of the angles. Well, the first one we've got to start out by using law of cosines. We don't have a choice. But let's bring that triangle in here. Okay, and let's just label things off. So I'm going to go ahead and start by labeling A. Well, A, they say, is 19 feet. Now remember, this shape is not to scale, okay? Just in case you're wondering. And then B, opposite here, would be 24.3. Notice I'm putting them opposite their vertex, the corresponding vertex. And then C is 21.8. They want us to find all of the angle measures. So we're just going to pick. We could pick A, B, or C. And that's what I'm going to do. And then we'll start solving. So let's get the proper equation written out for this. So I'm going to start by finding the measure of angle B. All right, that's what I decided I wanted to start with. Which means if you're looking at the layout of the different equations, I want to know angle B, then lowercase b is out here. So let's just write it out the form with b. So I'm going to say b squared equals a squared plus c squared minus 2ac cosine b. Okay? Notice that I have the lowercase b and then the angle b on the opposite side. That's how you set it up. If it was a, I would have a here and cosine a here. If it was c, I'd have lowercase c here, and that would also change the inside. So let's just plug in what we have so far. Okay, so b is 24.3. Put that in parentheses. A is 21.8 plus c, which is, oh, I'm sorry, I have them backwards, hang on. A is 19 feet, and c squared is, or c is 21.8. Minus 2 times 19 times 21.8. Cosine b. So we're going to do this one at a time. So hang on here. We have the 24.3 squared. I'm going to have to write really small here, is 590.49. Followed by 19 squared, which is 361, plus 21.8 squared, which is 475.24. And then I just do that multiplication of the 2 times 19 times 21.8, and that equals, so we'll go minus 828.4 cosine b. Okay, first thing I'm going to do is combine 361 and 475.24, and that equals 836.24. Now, I want you to avoid the mistake that some people make. They think that they're supposed to subtract that 828.4, this, from this, and that can't be farther from the truth. So make sure you don't do that, because this particular number is attached to cosine B, so the only way you can get rid of that is through division. So make sure you do not subtract. So we're going to do this the way we should do it. And some people will find shorter ways and quicker ways to do it, but right now you're just learning it. So first thing I'm going to do is subtract 836.24. So minus from both sides, obviously. And that will leave me with a negative 245.75 equals a negative 828.4 cosine B. Now, I'm going to divide by, obviously, negative 828.4, so that cancels that. Now, so that means that all of this equals the cosine of B. Now, we're looking for an angle measure. So that means I'm going to be using the inverse functions on my calculator. I'm going to be hitting the second and then cosine key. So what I want to do though is write this out, because what I'm really looking for is the measure of angle B. So the measure of angle B is going to equal, and actually let's just keep that on the other side where it actually is. So I'm going to say it equals the measure of angle B. But I need cosine, the inverse of cosine, and I need to put the negative 245.75 divided by negative 828.4. And that needs to go in just like that. So you're going to hit on the calculator, you're going to hit second cosine. Okay? That's what you're going to hit on the calculator. And then you're just going to type all of this into the calculator. Okay? When you do that, you get the measure of angle B equals 72.74 degrees, which we're rounding to 73 degrees. So I'm going to come up here and I'm going to put 73 degrees in here. Actually, oh, you can read that. Okay, I'm going to leave it there. All right, so that takes care of one of the angles. And now what's really nice is I don't have to use the law of cosines. I can use the law of sines now. So I'm going to give you a second to go ahead and figure out how to use the law of sines for this. And so pause the video and then come back and see if you have figured out both angle A and angle C. So you can use law of sines now, and then you can use triangle sum theorem. So I'm going to go ahead and work on that. So I'm going to do that myself, and we're going to see where you're at. So we'll come back in just a second. Okay, so hopefully you were successfully done completing all of the problems. So you'll see down here what I wrote in red. Oops. And you'll see what I had to do with this. I had to use the inverse because, again, I'm looking for an angle measure. So when I typed all of this into the calculator, I got 59 degrees. So I have 59 degrees up here, 73 degrees here, and then what you see is I use the triangle sum theorem information to find the last angle measurement. That is how you can find all three angles with this particular law of cosines. So the law of cosines takes a little bit of practice only because it takes a little bit of time to write it out. So just continue on, work on the law of sines and cosines. If you've got questions, by all means, let me know in the comments, like I've said multiple times. I'm happy to walk through any problem with you, so you just need to let me know. I'm sure your teachers will help you as well, but I am available and happy to help. So here we go. So this particular problem it's going from the SAS, which we have up here, side angle side, because it means I have a side and then I have an angle, okay? And for the sake of this one, I'm going to go ahead and I'm just going to change this. We're just going to pretend it's 39 degrees. It's just easier to work with than working with decimals. This one wants us to solve for triangle ABC. So we need to find all the extra side length and we need to find the other angles. So the first thing we're going to do is we are going to solve for side A. Okay, and it's actually an easier way to solve for law of cosines on this one because the a squared will be on the left side of the equation. So what I'm going to go ahead and do is write it out the way it should be. So it's a squared equals b squared plus c squared minus 2bc cosine a. And this will help us find side length a. Okay? Now, what we're going to do is plug our values in. We don't know a squared. We do know that b is 12, so 12 squared plus 14 squared minus 2 times 12 times 14 times the cosine of angle A. Actually, the cosine of 39 degrees. Go ahead and erase that. Okay. All right, here we go. A squared. All right, let's write all those numbers in. So everybody knows 12 squared is 144, at least I hope they do, plus 14 squared, which is 196. Then it's minus 2 times 12 times 14, which equals 336 cosine 39 degrees. Of course, I'm going to combine the 144 and 196, and that will give me 340 minus 336 cosine 39 degrees. Now, the next thing we're going to do is just go a equals, because it's just a squared, the square root of this whole thing. You can just type that in. Okay, second square root, and then don't forget, you should be in degree mode when you're typing this in. Then you'll get a equals 8.8814. And we're just going to round it to the nearest tenth because that's the standard we've been setting. So that means that this is 8.9. Okay? So now we have all of our side lengths, and now we just need to find angle B and angle C. So what I'm going to do is use law of sines again. So I'm going to go ahead and set it up right here as sine. Let me cover it. Wait, hang on just a moment. Okay, I'm going to draw a little line here so our work doesn't get caught together. And I will write it in a different color. Let's see if this works. So sine of 39 degrees over 8.9 equals the sine of B over 12. So sine of B is going to equal 12 times the sine of 39 divided by 8.9. And we're going to want to put that into inverse okay, and then over 8.9, and that will equal the measure of angle B. So let's go ahead and type that into the calculator and figure out what that answer is. So the measure of angle B is 58.0513. So we're going to just call it 58 degrees. Actually, yes, 58 degrees. A little trickier when you get these kind of weird numbers in here. So I'm going to go ahead and put 58 degrees up here. Then the last one we need to find is the measure of angle C. So we'll just write it in here like we did last time. Is just 180 minus 58 plus 39. And that is 97. And that is 83 degrees. Okay, so there, you've got your final answer there. And this is how you use law of cosines for that particular equation. Okay, let's move on. So this particular thing is the actual methods and meanings note sheet that we have for this particular section of chapter 1.2.1 and the review and preview, just to get you ready. I've spent the most of this video going over this. I like the letters on here because it ends up getting you ready for working with the unit circle, but we're not quite there yet. But just so you know, so they've got your tangent is opposite over adjacent, which you see here, which is y over x, and then sine is opposite over hypotenuse, and then cosine is adjacent over hypotenuse. There are two ways I like to remember this. SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But I also write it with the ratios, and students tend to like this because it helps them remember that the first thing is the actual trig function and the next two are their ratio. So you have it here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and remember, it is only with right triangles. Okay, so that takes you through the whole methods and meanings pretty much in detail. I know that this is just to help you with some review and preview, but there's a lot of students who did not get law of sines and cosines last year because of COVID. So please take a look at this video, try the problems you want to try, but then let me know if you need any help. You could, again, I think I've said it 5 times, maybe less, maybe more, I don't know. Leave me questions in the comments and I will get back to you if you need help. But you can also ask your teacher specifically about the questions if you have them. And don't forget, degree mode, degree mode, degree mode. And we'll see you next time. Thanks. Bye.